Hello guys, I'm testing this video. I'm just attach my mic with it. Hello guys. So this is our fourth video in the series of Maxwell equation. Today we discuss about the equation of kinematics. As usual, there is disturbance, noises of street. Maybe you hear some songs in the background like this. So bear with it, enjoy the song and the deduction. I have written something on board before this video started, so I'll show you. Maxwell's equations number 4 and 3 equations are there. These are the equation of kinematics. These equation can be written in different notations. I wrote this equation in v1 v2 form, and as the displacement, a is the acceleration, t is the time as usual. So in next few minutes I would derive these equations. Before deriving this equation, I want to tell you something how we derive these equations. So there are multiple ways through which you can derive these equations. One of the way is the graphical way, which children do learn in class 9th, I guess. And the another way which is important for you is by using calculus method, as little bit of calculus is introduces in class 11th when first in physics, because in mathematics the differentiation is is very far in according to mathematical syllabus. There is one chapter of on differentiation in class 11th, 5th, 6th, I don't know, because books are changing with time. The chapter reduce, I don't know, actually I don't uh, practice with mathematics regularly. And the class 11th, class 12th has two chapters in part 1 on differentiation. One is on differentiation, foundational differentiation. Another is on application of differentiation. And when you reach at part 2, there is a chapter, first chapter on integrals, which tells you how you can do integration, and the next chapter would be I think is application of integration. So these are three chapters in which you learn calculus in class 11th and 12th in mathematical course. But in physics you need little bit of knowledge of calculus. Even in chapter I don't want to call these topic as in chapter, whenever you study about straight line motion. So these equations are comes first in straight line motion, since you already know what are displacement, positions, velocity, acceleration, So these are equations. How these equations can be derived by calculus method, we would uh, see that in next few minutes. I have this board also in which I have previously written these equations, but the I am unable to set up the camera, so I think I should move to the another board. Uh, mm, just wait a little bit. Another background music. This is the equation. This is the way how I derive the equation. I want to explain to you this in a bit of seconds. First, the equation that we need to derive. We already know the acceleration is rate of change in velocity in our previous video. dA is equal to dv by dt. And if we shift dt towards a, we get dv is equal to a dt. And then we took integration. This integration of dv side is from limit v1 to v2, and here I didn't take any limits because it ultimately we need to convert t1 t2 interval as t. So this is the limit, and the next dv, integration of dv according to some maths formula. Any function which is integrating suppose this is the function, then the dx, if this is dx, then it becomes x only. So this is the formula where I have applied. dv becomes v, dv becomes v, and then we apply this limit, final limit minus initial limit, that I directly wrote here. And here just a at because there is no limit, so a is a constant and dt becomes at. So this is at. And now if you shift v1 to this side, it becomes v2 is equal to v1 minus v2. There is another notation with this equation are right, is as v used as a final velocity, u used as an initial velocity, and this is also in common way in which we drive. Here v is final velocity and u is the initial velocity. So this is how we derive the first equation. This is the second equation of kinematics, that is S is equal to V1 T plus half AT square. And you can write this equation since V1 can be U. So S is equal to U2 plus half AT square. So how we drive the we knows V is equal to rate of change in displacement or position, but position is nothing but a difference. Positions we relate to distances, 2 points between 2 points. Displacement is change in position. So ds by dt. So v dt is a ds because dt goes towards v, and apply integration. Ds become s and v dt. We at the place of v, we wrote our first equation that we already derived in first part, u plus at. Then applying integration, adding multiplying integration with this inner equation u plus at. This will give you the u dt plus at dt. And for after integration, u dt becomes ut, and half at square. How it becomes half at square? See, at dt. This is the case. So a is a constant, t dt, and there is formula if you have to integrate x whose power is n and dx. This is the formula. Then you would do x plus n plus 1 upon my n plus 1. So a t square by t, because there is power 1. T has one power, so 1 plus 1 is 2, and 1 plus 1 is 2, so this 2 and this 2, so half at square. That's how it becomes half at square. So entire formula is u s is equal to ut half at square. Let's go to the next formula of kinematics, third formula. This is how it looks. Just take a break before driving this third formula. And listening this music, I have difficulty to recognize the words, but the rhythm is good. There is no mic, so my voice is not good, but I'm just attacked. Now you can hear some improvement and maybe some noises. The third formula, um, let's drive it in a different way, little fuzzy, in a fuzzy way. So dv is equals to dA by, sorry, dA. Mm, A is equal to dV by dt. This is our last class. A is equal to dV by dt, and if this is multiplied with ds and divided by ds, then dv becomes ds. We can write this in this form. That ds written here and dt written here. We can do that, and ds by dt becomes velocity, and dv by ds is acceleration, and a ds is equal to v dv. So this is not our final formula, obviously, yes, but see after that. Hmm. Applying integration, ts and u plus at dv. So u dv plus 80 dv और ठीक है okay so oh, it becomes mhm, this is nothing but a velocity so velocity square by 2 uv initial limit and final limit and at tdv is a ds and integration of ds is as. Oh, I think we don't need to apply this v dv. So it becomes as, it becomes v square by 2 dv, huh? uv half v square minus u square. Huh? This is the 2as v square minus u square. So, uh, how you can derive this formula? I'm writing this in a better way. I'm just discussing and figuring out because I don't know whether I remember or not. So, let's write this on a formula in a proper way so you can understand step by step, not a fuzzy way. But I want to share you this because uh, before performing in classrooms, we have to perform this in our personal spaces, and those personal spaces and those personal studies we do make mistakes. So please don't think that teachers don't do mistake. I done this so many times, but I don't care to remember these things. These things just comes up if you know how to apply basic physics. So please don't try to remember. Please try to understand these. How this comes when you do mistake, you would recognize the mistake if you understand how uh, these formula actually derive. Uh, uh, a good background music. I don't think. I don't know whether it's disturbing you or. But I have to shoot. I have to shoot my fourth video because I don't have time. This is my uh, you can say commitment that I must post a video regularly. Even I don't get much of views because I didn't share this with anybody because first I think I have to make some first 5-10 videos after that I can share because short videos 15 minutes 20 minutes if a student wants to learn more so after some videos are made on a foundation explanation at least on mechanical world so they these information may have student do for a class 11th or class ninth also some way so let's stop this circling here and go to the third equation. Now let's explain the third equation to you. This is the third equation. Uh, so this is the third equation. For this, we remind this formula A dV by dt. Divide this formula equation and multiply with ds by ds and shift the ds to this side. That doesn't matter. So dv and ds by dt is velocity, so we write this velocity, and dv ds here is the acceleration. ds goes there, and v dv here, integrating both sides, space, no space there, so here a ds v u dv, and integrating this give you s, and v square, this is the formula of integration, that x and dx integration is equal to x to the power n plus 1 upon n plus 1 in last formula. So 2 because there is one, v square 2 outside, 2 goes in this direction, the a ds, this is the formula in this way. V square minus v square is equal to 2as. This is the third equation of kinematics. These are important equations. This is the third equation, and to derive this equation in front of you with this video. So please remember these equations used in multiple problems. Derivation may come, may not come in your exams, but you get the idea how we can get these equations from calculus method. Derived all three equations in for you in today's video. So this is the fourth video of Maxwell equation series. We are very far from our ultimate goal. This is just the fourth video which teach you how to what are the equations of kinematics and how to derive these equations by using calculus method. For exam, the derivations are important, it comes sometimes, but the equations itself are very important. They used in a number of problems from your book or from any other exam you are preparing for. So please take serious these topics for your exams. For now, we close this video. It becomes too long due to some struggles during shooting. Or comments, anything you would like to add, I can do to improve the quality of your understanding, anything you want to discuss. So bye bye.